shape of atomic orbitals. Shape of atomic orbital. Atomic orbitals. Shape of atomic orbitals. Angular probability distribution curve gives the probability of finding an electron. Angular probability distribution curve gives the probability of finding an electron in a given direction. Hence, it gives the shape of orbital. The size, shape and orientation of the different types of orbitals S, P, D, F, S, P, D, F can be obtained by wave mechanics. Shape of orbitals depend on the wave function psi. Shape of orbital depend on the wave function psi. S orbital. Which orbital? S orbital. All S orbital are spherical. All S orbital are spherical. All S orbital are spherical. The nucleus of the atom is present in the center. The nucleus of atom. We wait just 1 minute. Plus this z-axis, y-axis, and this is the x-axis. 1s orbital. Which orbital? 1s orbital. And this plus 1 orbital, 2 orbital. 1s, this is the z-axis, and this is the x-axis, and this is the y-axis. 1s and 2s orbital. 1s and 2s orbital. 1s and 2s orbital. 1s and 2s orbital. 1s orbital, and this is the 2s orbital. This is the 2s orbital. All s orbital are spherical. The nucleus of the atom present in the center, and which is denoted by plus. The nucleus of the atom is present in the center, and which is denoted by the plus. All s orbital of an atom are identical, spherical, but their size vary. All s orbital of an atom are identical. Is that spherical? But is that spherical? But their size vary. The shape of 1s and 2s orbital has been shown. This is the 1s orbital, and this is the 2s orbital. According to wave mechanics, if the wave function psi varies, only with the distance of the electron from the nucleus. If the wave function psi varies with the distance of the electron from the nucleus and has no angular term, the orbital will spherical. For such function, psi correspond to L equal to 0, hence S orbital are spherical. Hence S orbital are spherical. Function psi corresponds to L equal to 0, hence S orbital are spherical. S orbital are spherical. S orbital are spherical. For S orbital, for S orbital L equal to 0, that means azimuthal quantum number is 0 and magnetic quantum number m is 0. This shows that S orbital have only one orientation. That means S orbital has only one orientation. Only one orientation. So S orbital are spherical in shape. So S orbital are spherical in shape. In case of S orbital, there is equal probability of finding the electron density in any direction with respect to nucleus. In case of S orbital, in case of S orbital, there is equal probability. There is equal probability. There is equal probability of finding the electron. Electron density in any direction. With respect to the nucleus. In case of S orbital, there is equal probability of finding the electron density in any direction with respect to the nucleus. And next is P orbital. We talk about P orbital. We are talking about P orbital. Which P orbital? For P orbital, L equal to 1 and m equal to minus 1, 0, plus 1. L means azimuthal quantum number and m means magnetic quantum number. For P orbital, L equal to 1 and m equal to minus 1, 0, plus 1. Three values of M shows that P orbitals have three orientation. Three values of M show that P orbital have three orientation. Px, Py and Pz, which are degenerate, having the same energy. The subscripts x, y and z refer to the coordinate along which maximum electron density lies. These three orbitals are three-fold degenerate or triply degenerate. The p orbital are dumbbell shape. The p orbital, the p orbital, the p orbital are of a dumbbell shape, of a dumbbell shape. The three p orbitals are mutually perpendicular. The three p orbitals are mutually perpendicular. They have nodal plane where the electron density is found to be zero. They have a nodal plane where the electron density is found to be zero. The shape of p orbital is three-dimensional. P orbital is three-dimensional. P orbitals belong to different orbits, have different size and energy. P orbitals have a directional character. The shape of px, py and pz have the shape of px and py and pz. This is the y-axis and this is the z-axis and this is the x-axis. Then the px orbital, the shape of px orbital is this is the shape of p orbital in px. And the next py orbital shape, this is the y orbital y-axis and this is the z-axis and this is the x-axis. Then this is the py, this is the py orbital, and the shape is pz orbital is this is the z-axis, this is the z-axis and this is the x-axis and this is the y-axis. This is the y-axis, or this is the z-axis and this is the y-axis and this is the x-axis. Then the p orbital shape is as so. This is the p orbital shape. This is px orbital, this is py orbital and this is pz orbital. And next is d orbital. We are talking about d orbital. Next is d orbital. L equal to azimuthal quantum number is 2. Then the magnetic quantum number m equal to -2, -1, 0, +1, +2. The 5 values of m indicates 5 orientation represented dxy, dyz, dxz and dx2, dy2. The 5 values of m indicates 5 orientation represented by dxy, dyz, dxz and dx square minus y square and dz square. This is the phi orientation of d orbital. This is the phi orientation of d orbital. All these 5 orbitals are equivalent in energy. All 5 orbitals are equivalent in equivalent in energy, and are degenerate, 5-fold degenerate in dxy, dxz and dyz. In dxy, dxz and dyz, lobes are concentrated in between the orientation axis indicates in the subscript to D. For example, dxy orbital lies between the x and y axis. Dxy orbital lies between x and y axis. The set of these 3 orbitals is represented by T2G, group theoretical notation. T2G मतलब group theoretical notation. However, in dx square y square, dx square minus y square, the lobes lies along the x and y coordinates. Along the x and y coordinates, lies x and y coordinates axis, and in dz square and dz square, there are 2 lobes along z axis. There are 2 lobes along z axis with a ring in the xy plane around the nucleus. With a ring in the xy plane, in the xy plane around the nucleus. The set of dx square minus dy square, the set dx square minus y square and dz square and dz square orbital is denoted by Eg. Set in group theoretical notation. Group theoretical notation. Hence, Eg set is known as axial set. Hence, Eg set in group of theoretical. Hence, Eg set is known as axial set. While T2G set is called the non-axial set. The shape of d orbital are represent. This is the y-axis and this is the x-axis. Then the value is d orbital. This is the d orbital. That means The shape of d orbital of double dumbbell. The shape of d orbital of double dumbbell. And dxy. The next figure is this is the issue. This is the issue. So that means this is the z-axis and this is the x-axis and dxz. And next figure is dx square minus y square means this is the y-axis, this is the x-axis. Then the value is a shuan. And the fourth figure and the next figure, fifth figure, this is the dxy figure, this is the dxz figure, and this is the dx square minus y figure, and the next figure is this is the y-axis, this is the z-axis. Then the figure is show, and this is the figure is dyz figure, and next figure is dz square. Dz square figure is very important in case of competition. This is the z-axis. This is the z-axis, and this is the shape. This is the shape and lies xy plane ring, and this is the shape of orbital. This is the figure. This figure is the z orbital. This figure is z orbital. In next heading, we are studying about the difference between orbit and orbital. Okay, thank you.